Hello guys, welcome to our course on Python for data analysis. We'll be talking about external libraries in this section, and we'll explore how to utilize external libraries and packages in Python to extend the functionality of our programs beyond what's available in the standard library. In the previous video, we saw what are the modules and libraries that are part of Python which we don't need to install separately. So now we want to talk about external libraries that we need to install and can use to extend the functionality of our code in Python. Before we get started, you know what to do. Don't forget to like this video, subscribe to the channel, and put your question in the comment section.
9 to 5 data.
External libraries are also known as third-party libraries or packages, and they are collections of pre-written codes that provide specific functionalities to Python developers. These libraries are developed by communities and cover a wide range of domains, including data science, web development, machine learning, data analytics, and many more. So by leveraging these external libraries, we can access advanced features and tools that are not available in Python standard library. So this allows us to save times and effort in our development process. So in this video, we'll explore some of the commonly used external libraries in Python, like NumPy library, Pandas, and some visualizations library. But specifically for this video, we'll just take a look at NumPy library and the Pandas. So let's get started. Let's go to our Jupyter notebook and write some code and see how NumPy library works. So just like we explained earlier how to do importation of the library or modules we want to use. So let's start. We want to talk about NumPy, so we'll say we want to import the NumPy library. So we'll do import NumPy as np. So we'll do enter. So NumPy library means numerical Python, and so they are mostly used for mathematical activities and also for working with linear algebra to tackle most of the problem we encounter in linear algebra, like doing matrix calculations and so on. So now that we have imported NumPy as np, then we can create an array. So create a NumPy array. So we can store that into a variable and say my array. And then we do np, and then we have a method called array in NumPy. We just do array just for us to create a list of numbers, and we'll put them in square bracket and say 1, 2, 3, 4, 5. Then we can print this my array. So we have the list of array. So on this array that we have now, we can do a lot of mathematical activities on it. So for now, let's just say we want to get what's the average of these values, or we want to get the mean. So we have the main method in the NumPy. So we can say calculating the mean of the array, calculating the mean of the array. So let's store that into a value, mean value, and say np.mean, which is a mean method for getting the average, and then we'll pass the array into it, which is my array. So if we print the mean value, print mean value, then we get a value of 3. So the average of the number we have in the list is 3. Also, we can do some matrix activities on this array, but for now, since what we have is just is a list of array, so most of the time, if you look at it in matrix form, so we can say we have 1 by 5 matrix. We have a 1 by 5 matrix. So definitely we cannot really do much with this right now. So we can do some matrix activities like doing reshaping, like trying to change the rows and columns. So for now we will do something different. So let's create a random array, and then we can specify the number of rows and columns we want to have in our array. So creating a random array, create a random array. So say random np dot, we have a random.rand method, random.rand, and then this will ask us for the number of rows and columns we want. We want 3 by 3 matrix. So if we print our random array, so we can see now that we have a 3 by 3 matrix, which is 3 rows, which is 1, 2, 3, and 3 column, 1, 2, 3. So that's that about NumPy. We have a lot of things we can also do with NumPy, but for the purpose of this course, we just stop there and also explore Pandas. So Pandas is also a library for doing data transformation and data analysis in Python. So it is a very important library, and it's one that has allowed us to be able to transform our data into the way we usually do in Excel or some kind of spreadsheet. So let's start with importing Pandas. Import Pandas library. Pandas as PD. So we can create a Pandas series from the array we have. So, and it will be kind of surprising when we say we can create Pandas series from array. What we need to understand is that Pandas is built on top of NumPy. So there are some of the functionalities in NumPy that we'll be able to do in Pandas, and most of the time you have to import or you have to install these two libraries together for you to be able to work with Pandas. So let's create a Pandas series. So let's say my series equals to pd dot, we have a series method in Pandas, and what it does is that it turns an array into rows and column, and it gives it an index. So for example, we'll say pandas dot this series, and we'll pass in a list of numbers, say number 1, 2, 3, 4, 5. So let's print this. We can say print, let's say Pandas series, and we'll print my series. So we can see now that the array that we have initially, which is something like 1 by 5 matrix, has now turned to a 5 by 1 matrix and also having an index. The index has the value by the left hand side, which start from 0, 0, 1, 2, 3, 4, and we can see by the right hand side the series, the array that we have turned to a series right now. So we also have something we call Pandas data frame. If you look at what we have above, we'll kind of see that it's looking like what we usually work with in a spreadsheet, but not exactly. So Pandas data frame takes it to another level. Then we can actually have functionalities that we have in a spreadsheet, the way the data is being displayed in a spreadsheet. We can have that by using Pandas data frame. So let's create a data frame. Create a Pandas data frame. So to create a Pandas data frame, we are going to use a notation called JSON notation. JSON notation, which stands for JavaScript Object Notation. I know we haven't talked about this, but most of the time that is how data is being sent across the web. So in later lectures, we'll get to know more about that. But for now, for the purpose of this lecture, just try to pay attention to the way the data is being written. So we have, it is written in key value pair. So we have the key and we have the value together. So that's why we call them key value pair. So name, then we'll supply, we'll put a column and we'll supply, name is the value, then we'll supply the key. So we want to have the key in a list. We have a list of names. So we'll say John, Hema, Mike, and then we can have Sophia. And at the end we'll put a comma. So that means we are done with that key value pair. So we want to put another key value pair. We can say, let's say we want to have the age of these people we have just listed. Say age, which is a value, then key, we'll bring the key and we'll say 25, 30, 35, and we'll say Sophia, let's say the oldest, which is 40. And then again we can, let's say, have the city they live in. So we do another key value pair, city, and we'll give the list of cities. We'll say London, Paris, New York, say Barcelona, and let's run this. That's our data. So we can use Pandas data frame to convert this into something like a spreadsheet, in a spreadsheet format like we've seen on a spreadsheet. So what we'll do is we use the data frame method. So let's say pd.dataframe, and it takes in the data argument, the data as the argument, and we can save this into something like, let's say df, short form for data frame, and we can print, let's say Pandas data frame. Let's use that escape character here, Pandas data frame. So let's print our df, print df, Now you can see the way it is looking now, like some kind of a spreadsheet format. So we have the name as like our column header, name, age, city, and we have John and also the age and the city as the value. And by the extreme left hand side, we can see that we have our index again, just like we have it when we were talking about the Pandas series. Now DataFrame is better than the Pandas series in the sense that it presented the data in kind of a spreadsheet like format. So then we can then be able to do the kind of manipulation or anyhow we would like to manipulate the data. So we also have another method in Pandas which allows us to read different file formats. So for example, we have the read_CSV format, which will allow us to read a CSV data in Pandas. So let's start by saying pd.read_CSV, and we want to pass our value. For example, I have a document called football club on my PC, on my local PC. So football club .csv, and I can save this and say CSV data. So I can print the data and say print CSV data, and we should have this now. We have the club and the country they belong to. We have Manchester City belonging to England. So this is reading a CSV format, just the way it will look like when you open it with Excel spreadsheet. So we can also do some visualization in Python with the help of Matplotlib, a visualization library. So just the same, just like we have been doing initially. So let's try and import it. We'll say import matplotlib, and .pyplot as plt. So the next thing is that we would like to do some kind of visualization with this. So let's just create a kind of a dummy data. So we'll just create a list of numbers and then visualize them. So let's say data for plotting. So we can say x equals list of number 1, 2, 3, 4, and 5. So let's do our y variable and say 2, 4, 6, 8, 10. So let's run this. Then we can plot a line plot. Say line plot using Matplotlib. The first thing we need to do is to access the plot method, which takes into argument the x and y value. Then there are other methods like the title method, the x label method, the y label method. The title method allows us to add title to the plot. The x label method allows us to add title to the x-axis and also title to the y-axis, and then the show method will allow us to be able to render our visualization. So we'll just do a quick rundown of everything I've explained, and then in later videos we'll get to understand how these things are done in deep, and we'll dive deep into other methods that we cannot explain now. So let's say plt.plot, which is a method for plotting and is x, y, and after that we have plt.title, which is the method which will allow us to put the title in this, and say let's say line plot, and we want to do the x label, which is plt.xlabel, can say X label, and also for the Y label we do the same thing, plt.y label, Y label. So for us to be able to render the visualization, we do plt.show, and it doesn't take in any arguments, just we run that, and now I think there's an error in this, or it should be plt.show. So we have our visualization now, and we can see what we have just plotted, the x-axis and the y-axis. So now that we have covered some of the commonly used external libraries in Python, we move on to cover some of them deeper in the coming videos, and we'll start by looking into NumPy and going deeper into NumPy and see how we can do a lot of manipulation with NumPy. So we have come to the end of this video, so don't forget to like this video, put your question in the comment section, and subscribe to this channel. Happy coding.